Hi, this is Rosie. You are welcome to my channel. You are very much welcome. Okay, this is continuation of our circle theorems. I want us to look at some past questions on circle theorems, okay? Okay, and number one, we have the diagram already there, and we have a circle ABCD with center O, Okay, let me use pointer to show you. This is our circle, and circle ABCD has a center O. Radius is 7 cm. Okay, we have two angles here. We have angle AOC. Angle AOC is 190 degrees, and we have another angle DAO. This is DAO, angle 35 degrees, and we are asked to find these angles. Okay, the first is angle ABC, and then angle ADC. Okay, let me show you where the angles are. So angle ABC is formed at B. This is the place. And the angle ADC, this is angle ADC, is formed at D. Okay, so now let's solve. Get your pen and paper. Let's solve together. So I have my circle back again, and we are to work out for angle ABC. So how do we find angle ABC? Which is the inscribed angle here, ABC. This is the inscribed angle, and here is its center. So how do we work it out? So here angle AOC is twice angle ABC. Reason is because of angle at the center is twice the inscribed angle. So this is the angle at the center, 190 degrees, and here we have angle ABC, the inscribed angle. So here it is. Okay, so we'll make ABC the subject by dividing through by 2, and that gives us 95 degrees. So angle ABC is 95 degrees. The second part says we should find angle ADC, the angle at D here. So we have a centric quadrilateral ABCD, and this angle ABC, that's the angle at B, an angle at at D, B and D. Okay, the angle at B and angle at D are opposite interior angle of this centric quadrilateral, and we know their connection. They will give us 180 degrees. If we sum angle B and angle D, they will give us 180 degrees. So that's why we are having angle ADC plus angle ABC to be 180 degrees. So we substitute for ABC. Okay, substitute for ABC, make ADC the subject, and we have our results. So we have ADC equals 180 degrees minus 95 degrees, giving us 85 degrees. So angle ADC is 85 degrees, while angle ABC is 95 degrees. You can try that yourself. Okay, here we have our number 2. We have also another diagram. We have another diagram here, a circle and an angle 200 degrees at the center, and we are asked to find the value of x. Okay, so you can see the diagram. And let's solve. Okay, so I repeated the diagram here, and I want to explain. From what we did, we had this diagram. I added some things. Now I divided this into not 2 equal parts, but I divided it into 2. Now here is this. Let me use pointer. Okay, I repeat. This I divided into 2, not equal, but I divided it into 2. And you know this is the center. From here to here is the radius, from here to here is the radius, from here to here is the radius. And if that be the case, it means that the angle here and the angle here are equal, isosceles triangle. Angle here and angle here are also equal, isosceles, the base angles of isosceles triangle. Okay, with that now we can say that if here is 200, the angle here will be 360 minus 200, which is 160. Okay, here is 200, here is 160. Reason is because angle at the point is 360, so we subtracted 200 from 360 and we have the angle here, which is 160. Now to solve, we have 160 degrees is twice the inscribed angle, and here is its inscribed angle here. So the inscribed angle is 30 plus x, 30 plus x. Okay, 30 plus x is the inscribed angle for this question. Okay, so we now open the bracket and we have 2 multiply 30 giving us 60. That's what happened here. 2 multiply 30, we are opening the bracket. 2 multiply 30 will give us 60. 2 multiply x will give us 2x. Okay, and then we will take the whole numbers to one side of the equation, so we have it on the right side of the equation, and I will now make 2x the subject for now. Okay, and then we have 160 minus 60, 160 minus 60, which if we subtract will give us 100, will give us 100. So we have 2x to be equal to 100, but that is not what we are looking for. We are looking for x itself, so we divide both sides by 2, and that gives us x to be 50 degrees. So the value of x is what? 50 degrees. So try it again and again and again. You can do it, I know you can. So try it. Alright, this is our number 3, and this is our diagram. This is our diagram. We have our diagram. We have TP to be equal to 12 cm. This is our TP. Let me use our pointer to show you. Okay, this is our TP. Our TP is 12 cm. Okay, and we are told that this TP is 6 cm from O. That is here, 6 cm. From here to here is 6 cm, and O is the center of the circle. We have to find angle TOP, TOP top, TOP top. Okay, so let's find angle TOP. So I have my diagram again. Now I have I have my diagram. This is the circle, and this is TP, and this is O. That is from O to TP, the 6 cm. Okay, if this divides, now we'll have 2 right angled triangles. We have 2 right angled triangles. Okay, and this will also give, since this is the center, it will divide this into 2 equal parts. It will divide this into 2 equal parts. Okay, so if this from T to P is 12 cm, that means if this divides into 2 equal parts, here will be 6 and here will be 6, and then we will work at the remaining. So let me show you how I did it. Already is done. Okay, so I have to bring out one of the triangles. Okay, so let's solve now. So having one of the triangles, I figured out that the trigonometrical ratio that will do the magic is tangent. So tan theta will be 6 over 6. That is opposite over adjacent, and opposite is 6, adjacent is also 6. So dividing, we have 1. So we'll find the tan inverse of 1, which is 45 degrees. Tan inverse of 1 is 45 degrees. And since we are looking for angle TOP, which is twice the angle we have here, because it divided into 2 equal parts, that means we have to multiply 2 by 45 degrees, and that gives us 90 degrees. So angle TOP, angle TOP is 90 degrees. Okay, Our number 4, we also have another circle. Remember, we are dealing with circle today. So we have another circle. Our circle is here, and the center of the circle is also O. Okay, this is the center. We have so many letters, so let's explain. We have angle OQR. OQR, that is this angle OQR. OQR, that is angle formed at this Q, and that is 32 degrees. We have another angle given, that is angle TPQ. TPQ. TPQ, that is angle 15 degrees. And we are to find angle QPR. QPR. So this is our QPR. That is this inscribed angle here. This is what we are looking for. Angle at this P. Angle here, not this one, but this one. Okay, let's solve it together. Okay, here is the solution. I'll have to repeat my diagram so that I can use it to explain or see what actually is given. So here is the diagram again, and we are looking for angle QPR. Remember, that is what we are asked to find. Angle QPR. Okay, so let's work it together. Angle QOR. Angle QOR. Let me use pointer to show you the angle. Angle QOR. QOR. That is the angle here. Angle here. Angle here. QOR is twice the angle here. Okay, is twice the angle here. The angle at the center is twice the inscribed angle. Okay, all right. Okay, since it's twice and this is it, if we make QPR the subject, that means it is half of angle QOR. Okay, so let's see. We have a triangle in the triangle. There are so many triangles, but the one we are going to use now is triangle QOR. This is the triangle. This triangle QOR. Triangle QOR. Okay, that's the triangle we want to use now. Triangle QOR. This triangle here. So I want to use it to solve. So this triangle is an isosceles triangle, meaning that the base angles are equal. The base angles are equal. So since here is 32, from here to here is also what? 32 degrees. Okay, it's also 32 degrees. Isosceles triangle. So the base angles are equal. So that's number 1. And that will help us to find the angle at the center. So with that, now we apply the sum of angles, the sum of interior angles of a triangle, giving us 180. And then we apply, we have 32 degrees plus 32 degrees plus angle QOR to be equal to 180 degrees. So make angle QOR the subject, and you have 180 degrees minus 64 degrees, and that will give us 116 degrees. Okay, now that we know this, the next is to substitute it in this particular equation, in this. Okay, so we substitute and we will have this. Okay, so this is what will happen. Okay, recall, so you substituted, we substituted, and we divided 116 by 2, and that gives us 58 degrees. 58 degrees. So the angle here, the angle QPR, the inscribed angle here is 58 degrees. Is 58 degrees. Okay, we have a number 5, and we have the circle given to us. Remember, we are dealing with circle today. So here is our center O, and we have angle SQR, SQR, SQR. This is it. SQR, the angle formed at Q here, that is 60 degrees, and we have XPR, SPR is here, Y, and we also have SOR, which is 3x, and we're asked to find the value of x plus y. I mean, we're going to find x and also find y, then sum them together. So let's do that now. Okay, like I used to do, I repeat my circle again, and then we solve together. So look at what we have here, that this angle at the center, this is the angle at the center, is twice this, either this or this. Okay, both of them is twice this and also twice this, so it depends on the one you want to work at. This is angle at the center of these inscribed angles. Okay, we have two inscribed angles here, and remember y is equal to 60 because both of them are formed by the same arc. Okay, so y is equal to 60. So it's either you say that it's equal to 2y, or you say it's equal to 2 times 60 degrees. But note that y is equal to 60. Okay, we go on. Okay, so what we did is, using this now, we multiply it by 2 and we have our 120 degrees. Then make x the subject by dividing both by 3, and we have our x to be equal to 40 degrees. And remember I said that y is equal to 60. So this is it. So we have our x plus y to be 40 plus 60, which is 100. Okay.